Alright, so this is chapter 6, mechanics. So the linear velocity of the rim points of a uniform rotating disk is 3. Okay, whatever. I'm gonna give all the formulas. This chapter is all about UCM, okay, uniform circular motion. Very easy. Okay, we're gonna start with the main ones. Is that V is equal to R omega, and A is equal to R alpha. This is A tangential. Well, this is V tangential, or if otherwise known as linear velocity. Alright, this is the first two formulas. Very straightforward. What is W? What's alpha? W is known as omega, and it's the change in theta with respect to time. This is known as the angular velocity. And it's theta final minus theta initial over delta t. Now, let's say you want to make a derivation chain. Omega is actually equal to the derivative of theta with respect to time, and alpha is equal to the derivative of omega with respect to time. Alright, what's alpha? Alpha is the angular, yeah. 4 is alpha. What is alpha? Alpha is the angular acceleration, and it's equal to delta omega with respect to time. So it's omega final minus omega initial over delta t. These are all circular motion formulas, so this is all on a circle. So r would be the radius, and theta is the angle that is displaced by. This is the theta. Okay, if you're going from point A to point B, this is the theta. Okay, and this is theta is in radians. Okay, 5. Let's talk about. I can't really think of any right now. Because I think we can start with these. If there's anything I see, I'll add it as we go. Oh, let's look at centripetal acceleration. Basically, there's two accelerations on a circle. There's a tangential acceleration, AT, which is along the tangent, and there's the centripetal acceleration, which is along the center, and it pulls you towards the center. This is otherwise known as normal acceleration. A centripetal is equal to V squared over R, or R omega squared. These both work, okay? And let's say you're asked to find the net acceleration, or the total acceleration. Since it's a vector of two different quantities, you simply take the magnitude of two vectors. So radical AC squared plus AT squared. Alright, so these are the formulas that I remember so far. If there's anything else, we'll add it as we go. There's another formula that I forgot to add, is that when you move from A to B along an angle theta, theta is the angle that you are displaced by. This is called the angular displacement. Alright, the main formula that you need to know is, let's say this is an angular displacement. Let's say I want to find the length of the displacement. So this is the angular displacement. How much is the length? The length would be the length of this arc here. How do you find that? That's simply L is equal to R theta. Okay, basically, so this length here is the length traveled from A to B. Over here, the linear velocity of the rim points of a uniformly rotating disk is 3 meters per second. They gave me linear velocity, so they gave me V. Okay, whereas the points located 10 centimeters closer to the axis of rotation have a linear velocity of 2. So this is V2. Okay, this is V1. What is the radius of the disk? This question will come pretty much copy paste, but it's just going to change the numbers. You need to understand that you have 2 points on the same rim, but one is just a bit closer to the radius. So if you want to draw it like this, it's kind of like you have a point here, and you have a point over here. So this point B has a smaller radius, it's called R2, and this A has a bigger radius, R1. They're both rotating at the same rate, so they both have the same omega. Okay, what's omega? Omega is V over R. So since they both have the same omega, that means V1 over R1 will be equal to the second omega, which is V2 over R2. So when you see this question in your exam, simply do V1 over R1 equals V2 over R2. Why? Because these are still on the same, they're still on the same disk. They're on the same disk. So that means they're both having the same omega. What do I mean by the same omega? Isn't V equal to R omega? Yes. Now since both of them have the same omega, that means omega 1 is equal to omega 2. And isn't omega 1 just take R to the other side? Isn't omega 1 just V1 over R1? Isn't omega 2 just V2 over R2? Simply that's how you get the rule. Okay, this is how you get the rule. But in your exam, you don't gotta do all that. Just put this in. How do you put this in? V1 is 3 meters per second. With this point here, for the 3 meters per second, is on the rim. So that means the radius of it is r. Equals V2 over R2. The second velocity is 2. Over the second radius, which is this original radius, but it's 10 centimeters closer. So minus 0.1. Why 0.1? Then it's centimeters. Why did I do minus 0.1? Because it's closer to the axis of rotation. So if you have the circle, point A is here, point B would be over here, which is 10 centimeters closer. Okay, so you get this. Cross multiplication will get you r is equal to 0.3. Now part B, since you found the radius, can you find the angular velocity omega? Yes, we can. Omega is v over r. So it's going to be 3 over 0.3, which is 10. Alright, over here, the rotational motion is theta, 1 plus 2t plus t cubed. What is the instantaneous angular velocity at t equals 2 seconds? So they want you to find omega at a certain time. As I told you, if you have an expression for theta and they want you to find omega, you simply just derive it, okay? Simply. So if you want to find omega, you derive theta and you get 2 plus 3t squared. Since they want it at 2 seconds, فبتكب فيها 2, it will become 2 plus 3 times 2 squared, which is 14. The unit is radian per second. Obviously, this is positive. If it's positive, that means it's counterclockwise. When would it be negative? Only if it's clockwise. If it's clockwise, then it's negative. Since it's positive, it's counterclockwise. Alright, over here, again, they give you theta, but now he wants angular acceleration. Angular acceleration, alpha is the second derivative of theta, so it's d squared theta by dt squared. Okay, so you gotta derive twice. So first derivative will be 2 plus 3t squared. The second derivative will be 6t. Now they want it at 2 seconds, فبتكب 2 جواتها, فit becomes 6 times 2, which is 12. Over here, since it's positive, and it's obviously in the counterclockwise direction. Q4. A wheel at rest starts rotating with angular acceleration alpha is 2. After 0.5, the magnitude of the wheel's acceleration is 13.6. What is the radius? In the exam, the answer was 69. Okay? I don't know. Maybe he might change it. But let's do it regardless. When he gives you alpha, or he gives you time, he wants the wheel's acceleration. What is the magnitude of the wheel's acceleration? There's only one formula for the magnitude of the acceleration, and that's a is equal to radical ac squared plus a tangential squared. They told us this is 13.6, so 13.6 is equal to radical ac squared plus at squared. Let's get rid of this radical, so we're going to get 13.6 squared equals ac squared plus at squared. They gave us alpha. Can we find at? Yes, we can. So 13.6 squared equals ac squared plus at. A tangential, remember, a tangential is simply r alpha. So r alpha squared. What's ac? A centripetal, can we find it? A centripetal has two formulas, v squared over r and r omega squared. How do we know which one we're gonna use? Over here they gave me angular acceleration. So can I use the linear velocity? No, this is angular, so I have to use angular velocity. So I'm gonna use r omega squared. So 13.6 squared equals r omega squared plus r alpha squared. Now what's the problem? We don't have omega. Let's remember that in UARM we used to have v is equal to at plus u. Same thing here. Omega is equal to alpha t plus omega node. Since it's starting from rest, omega node is 0. So simply omega will be alpha, the acceleration, times the time, 0.5, which is 1. So over here we're going to substitute the omega with 1. So 13.6 squared equals r squared plus r times alpha is 2, so 2r squared. So it's going to be 13.6 squared equals r squared plus 4r squared. So you're going to get that 5r squared equals 13.6 squared. Getting rid of squaring and then divide by 5. you get 6 centimeters to the nearest integer. Alright, so this is the answer, huh? 6. In the exam you can always write this. If you see the same question, what comes, same thing, but you just change the numbers. Write this: a squared, acceleration squared that they give you, is equal to r omega squared plus r alpha squared. هذه double square. Okay, this will work every single time, but the problem here that you just need to do is find the w, and you can find it, as I told you, by doing this. Just multiply the acceleration with the time. Okay, so if you want something that will always work, it's r alpha squared t squared plus r alpha squared. But I don't think you want this. I think the first one is better. This one's a bit better. I don't know, whatever you want, but these are both formulas that will work. Alright, at t equals 0, a wheel rotates with angular velocity omega equals 5. If the angular acceleration is -2, the angular displacement is what? Okay, this is where you need to use the UACM formula. They gave you time, they gave you omega, they gave you alpha, okay, and they want theta. Okay, you need to know this formula. Theta is equal to half alpha t squared plus omega t. This is used like which formula? What does this look like? It looks like x is equal to half a t squared plus v initial t. We took this a long time ago. So basically, it's these same formulas that can be applied in UACM. If you want, I'll write them down. So I'll just say UACM. Omega is equal to alpha t plus omega node. Theta is equal to half alpha t squared plus omega node t. And omega final squared minus omega initial squared equals to alpha theta. Anyway, so applying this formula, you're gonna get theta is equal to half -2 4 plus 5 2, and you get, they want it in degrees, huh? So the answer you get is always in radians. So you get -4 plus 10, so you get 6. Okay, this is in radians, so theta is equal to 6. With the answer you get is always in radians, but they want it in degrees. So what do you do when they want it in degrees? How do you convert from radians to degrees? You multiply by 180 over pi, and you get 344 degrees over here. Over here, a small car of mass 0.8 is traveling at a constant speed inside a vertical circular track of radius 5 meters. The normal force exerted by the track on that car when it's at the top of the track is 6 newtons. Take G equals 10. What's the normal force on the car when it's at the bottom of the track? This is very easy. I'm gonna draw it for you so you know what's going on. Basically, there's a car that's going through a vertical track. There's a circular track, kind of like the Hot Wheels track. So it goes up, then it goes back down. Okay, so this is like how the car moves. Alright, it goes to the top, then comes back down. Alright, the radius here is 5 meters. The mass is 0.8 kilograms. They want the normal, they told us that the normal force on the track when it's at the top of the track is 6 newtons. So over here, what's the normal force? It's 6 newtons. But how does it look? It goes down like this. This is the normal force because it's the surface pushing on the car. What else? What other force is pulling this car down? Isn't it the weight as well? Yeah. They're saying what's the normal force on the car when it's at the bottom of the track? Over here, what's the normal force N? Is the weight going upwards now? No, the weight is downwards. So simply, over here, N will be equal to W. Wait, no. Hold up. Now, you can do this in a very easy, very easy way. The rule is simply, you can do this, that the normal force at the bottom equals the old normal at the bottom equals the normal force at the top plus 2 times the weight. This works every time. So the normal force at the top they give it to us at 6, and then the weight is 0 mg, so 0.8 times 10, which is 8, and times 2 because that's the rule, and you get 16 plus 6, which is 22. This works. Now I want to give you some backstory behind it, why I get that. Okay, at the top, always in circular motion you have a centripetal force Fc. Okay, the centripetal force at the top is N plus W. Now that means the centripetal force at the top should not be different from the centripetal force at the bottom because the speed didn't change, it's at a constant speed. So that means at the bottom, what's the centripetal force? N minus W. N minus W at the bottom should be equal to N plus W at the top. So that's simply what you gotta do. Taking W to the other side, you get N is equal to N plus 2W, where this N plus W, since it's the same, this is the top. Okay, so you know which one's which. Okay, so easy. So it's gonna be 6 plus 2 times 8, and you get 22 newtons. Alright, again, these are all good questions, so they're gonna come 100%. A particle covers a linear distance of 4.8. Linear distance, linear means L. There's only formula that relates L, by the way, and that's L is equal to r theta. So we're gonna just keep that in mind. It subtends a displacement of 2.4 rad, that's theta. Given that the tangential acceleration is 1.2, so this is A tangential, they want angular acceleration alpha. Now, how can we find alpha if we have A tangential? We know that A tangential is equal to R alpha, so alpha will simply be A tangential divided by the radius. But what's the problem? We don't have the radius, but if you can see here, they gave us L and they gave us theta, and how can we relate these two? L is equal to R theta. So you can actually find the R by doing R is equal to L divided by theta. So that's 4.8 divided by 2.4, which is 2. So that's your R. So over here, you can substitute 80, which is gives us 1.2, over the radius R, which is 2, and you get 0.6. Over here, a particle is moving in circular motion, and this is its equation. Select the graph that represents the correct variation of the angular velocity with time. Alright, this is very easy. أول شيء, you need to check that this is theta, right? And they want angular velocity. For what you have to do is derive this. So we need to find the graph of the derivative of this. What's the derivative of this? Omega will be 2t plus 0.5. So this is omega. We want to graph the angular velocity, so this is what you need to graph. Now, how can you graph this? أول شيء, it needs to be starting from 0.5. 2t plus 0.5. Is this starting from 0.5? No. Is this starting from 0.5? No. These two are both starting at 0.5. So how can we find the difference between them? It's 2t plus 0.5. Alright? You can actually just check each point. Like مثلا substitute t equals 1, you're going to get 2 times 1 plus 0.5. So you should get 2.5. Which one has 2.5 at 1 second? This one is that one. Alright? Over here, at 1 second, you can see it's just like 0.9. So obviously this is wrong. We need it to be 2.5. And this is the only one that has 2.5. Alright, over here, a student wants to study the motion of a ball in circular motion. He attaches a ball by a short rope of 70 centimeters, and he hits the ball using a tennis racket. Using the ball's motion. Alright. The ball is kept in uniform motion in a horizontal circular motion, as shown below. The ball rotates theta equals 45 degrees in 0.6 seconds. What is the value for 45 degrees in radians? How do you convert something to radians? You multiply by pi over 180. And you get pi over 4, sorry. What is the angular velocity in 0.6 seconds? Why did we find it in radians? Because over here in part B, they want to find angular velocity. And angular velocity is equal to delta theta divided by delta time. Delta theta, they give us 45 degrees, but we can't use it. It has to be in radians, huh? So that's why they made us find it in radians. So delta theta is pi over 4 over the change in time, which is 0.6 seconds. And you get 1.3. Then we go down to part C. If the ball was to suddenly separate from the rope after 0.6 seconds, what is the initial velocity of the ball? So they want to find the velocity. Very easy. Did they give us the radius? Yeah, they gave it. Okay. What is this? That's something else. Hold up. Alright, over here, when they're saying what is the initial velocity over here, they're talking about meters per second, so that's v. And there's only one formula that can relate the angular velocity over here to v, and that's simply that v is equal, it's simply that v is equal to r omega. And the radius here is given to us 70 centimeters, so 0.7 meters. So simply is gonna be 0.7 times 1.3. Ooh, that gets you 0.91. Alright, over here the figure below shows a Ferris wheel at a local amusement park of radius 23 meters rotating anti-clockwise. The passengers travel at an angular speed 0.24. What's angular speed? That's omega, that's w. The speed of each passenger. When they say speed, they're basically asking for v. How do you, we have r and we have omega. How can we find speed? What's the formula? V is equal to rw. So it's gonna be 23 times 0.24, and that gets you 5.5. Select the diagram that correctly shows the direction of the centripetal force and the direction of the linear speed on capsule A during its motion. This is very easy, okay? So pretty much the v is linear and goes in the direction of motion. Since we're going counterclockwise, easy peasy, it goes up. How about the centripetal force F? The centripetal force F is called centripetal because it points towards the center. Okay, so it has to be this one. No, it's this one here. Yeah. This one over here. Part C, the duration that the passengers take to ride on a full cycle is what? To ride on a full cycle, that means that the theta is a full circumference, one full circumference. And how many degrees is one full circumference? 360 degrees, but now we're working in radians, so we're going to say 2 pi. How much is the time? Let's see. How much is the time? Isn't omega equal to theta divided by t? Yes. So that means the time will simply be theta divided by omega. The theta is 2 pi, with the omega is 0.24. So 2 pi divided by 0.24 you get 26.2 to the nearest integer 26. There you go. Alright, so over here, consider a car rounding a curved track of radius r. The track is banked at an angle theta from the horizontal. How does the FBD look? Very easy. Pretty much this is how it looks. You need to know why though. Alright, so basically this here is like, you know those race cars in America, it's called like NASCAR. It's like a circular track, but that track isn't like flat, it's like tilted upwards, if that makes sense. It's inclined, it's an inclined track. So if you're moving around, obviously then the normal reaction will be pushing you up, and obviously the weight will be pushing you down. This is a given. Everyone knows this, and it's grade 12S. Now the thing is here, where do we place the friction? Friction is where many people get confused in this exercise. Friction will be placed towards the inside, because here you're on a circle. Okay, you're on a circle. You're moving around over here, it's going to continue and go back. You're on a circle. Anytime you're on the circle, there should be a force that goes towards the inside that pushes you in. Now why is it pushing you in? It's the nature of the car to slide off the circular pathway. But friction is the centripetal force preventing you from disturbing your circular motion. So that's why it keeps you intact, keeps you in the circular phase. So for that case, friction will always be pointed towards the center. Alright, let's continue. What can be said about the centripetal force acting on the car? The centripetal force, basically, if you're asked what is the centripetal force, you need to find the resultant x components for all of these. So you need to find the x components. That will be centripetal force, because The centripetal force, as the name suggests, is basically the force acting in the direction of the center. It's not a force that you put on your free body diagram. It's not. It's just a force that's theoretical, that we have it for us. You don't draw it on your free body diagram. What can be said about it? Simply, how can you find the centripetal force here? What are the forces that are acting towards the center? Friction, you need to find its x component. What's N? It has an x component? Yes, it does. W does it have an x component? Yes, it does. That's all you need to do. Okay? Yani, it's provided by a combination of x components with normal and frictional forces. Alright, question 12. Alright, a ball attached to a string on one end is swung in a circle of radius 1 meter according to the equation here. Theta t is 5t squared plus 2t, where theta is in radians and t is in seconds. What is the angular acceleration of the ball? That's the first thing. هلا هون they gave us the expression of theta. How can we find the expression of angular acceleration? We must derive twice. For omega would be the first derivative, which is 10t plus 2. Alpha is gonna be 10. Okay, so what is the angular acceleration? It is just 10. What's the linear speed at t equals 2 seconds? V is equal to r omega. This is the linear speed. So it's gonna be 1 times omega, which we don't know. But can we find omega? Yes, we can, because we found the expression for omega. Okay, so it's 10 times the time is 2, so 2 plus 2, which is 14 rad per second. So let's multiply this now, but hold up. I'm saying I did something wrong. 10 times 2 plus 2 is not 14, it's 22. That's why I was bugging. It's 22 rad per second. So you get V is equal to 1 times omega, which is 22. So your answer is 22 meters per second. Over here, they gave you the radius is 2.5. They said that t equals 0, the acceleration is 2, so they gave us alpha. They gave us the angle 38, that is 38. What is the angular speed at t equals 3 seconds? If you have alpha and you have the time, can you find omega? Yes, omega is equal to alpha times t. V is equal to at plus omega initial, but at t equals 0 it starts from rest, so that means this is 0. So it's going to be omega is equal to 2 times 3, which is 6. The linear speed at point P, linear speed V is equal to r omega. So you simply multiply the 6 by the radius 2.5. Alright, the total acceleration of point P is how much? To find the total acceleration, A net is equal to radical AC squared plus AN squared. No, as the AT squared, مش AN. So, A centripetal is V squared over R. So radical V squared over R. Don't forget it's A centripetal squared, so squared. Plus A tangential squared, AT squared, which is R alpha squared. So it's going to be radical V squared, so 15 squared over the radius 2.5 squared plus R alpha squared, so 2.5 times alpha, which is 2 squared, and you get 90 meters per second squared. Over here, the graph below shows the variation of the angular position during 10 seconds. What is the total displacement? Akid, if you're going from pi to minus pi, how do you find the displacement? You just do theta final minus initial. Yani, it's so easy. So negative pi, which is the final, minus the initial, which is pi. So you get negative 2 pi. What is the average angular velocity of the particle? Angular velocity is equal to change in theta divided by change in time. So it's negative 2 pi divided by the time 10 seconds, which is negative 0.2 pi rad per second. Alright, over here, question 15, the figure shows a disk of radius 15 centimeters speeding up anti-clockwise. The magnitude of the tangential acceleration is 1.2. So they gave me AT is 1.2 meter per second squared. The magnitude of the angular acceleration is how much, and is directed out of the page. Now, A tangential, and they gave us the radius r, they want angular acceleration alpha. Which formula rates these three, at, r, and alpha? A tangential is equal to r alpha. So 1.2 equals 0.15 times alpha, which is, we don't know it. When you divide, you're gonna get alpha is equal to 8 rad per second squared. Now it's positive. When something is positive, it's with the direction of motion. As you can see here, this is a dot. When it's a dot, that means out of. If here the answer was negative, then it would be the opposite of this. Dot means out of. Okay, I just want to put this. Dot means out of. X means into. Okay, when your acceleration is positive, that means you're going along with what's written here. This is out of, so that means your answer will be out of. If your answer was negative, then it would be opposite to this and it would be into. Alright? If instead of this was an X, then it would be positive, and X, that means into. Okay, so that's the whole idea. Alright, moving on. Select the diagram that correctly shows the direction of tangential and normal components of acceleration at A. Always, tangential component is the one on the tangent, so AT. With the normal component or a centripetal component, like I told you, it has two names, normal and centripetal, is always towards the center. So easy. Okay? A and B are positive constants, and T denotes time. What's one expression of the angular position theta, which rotates uniformly and anticlockwise? أول شيء, if it's uniformly, that means no acceleration. If there's no acceleration, that means the degree must be 1. Yani هون there's no squared, there's no cube, there's no power 4, okay? The degree must be 1. Okay? Anti-clockwise معناتها positive. As you can see here, theta is equal to a plus bt. There's no acceleration. That means the degree is 1. That's why we don't choose any squares or whatever. So it's a plus bt simply. Here, a. Basically, هون theta, remember omega is equal to theta divided by time. This is for uniform when there's no acceleration. So theta is simply just omega times time. Okay, plus theta initial أكيد. This is easy. Now, when they want the angular velocity, if it's uniformly, then it should just be a constant, right? If you're rotating uniformly, that means you have constant velocity, right? Constant omega, right? So that means omega will just be equal to a number a. But since it's clockwise, that means it's negative. So it means it's negative a. By the way, thank you so much for watching, and good luck in your exam.